So welcome back, guys. It's now the 15th.
Hello.
We have somebody new joining us today. Joe, if you want to give a quick 5-second intro about yourself.
Sure. Hey, I'm Joe. I've been a software engineer for about 5 years now, mostly startup stuff, and happy to be here. Just excited to do some problem solving.
Yeah, happy to have you. Joe is also our Python instructor. And so I'm not sure if you're going to be doing yours in Python or not. Obviously, it's something that you know a lot, but I'm sure you know a lot more because you're also a full stack programmer. So I'm sure it's, it goes beyond Python. But welcome. And you haven't done the questions yet. No. So we're not going to obviously put pressure on you to solve any of these on the spot.
Just keep watching. Okay.
It's not a job interview. But feel free to pitch in with any kind of comments and any kind of insights that you might have. I think as we start going further along in these questions, we're going to hopefully find more variety in approaches and the way that we can give input for each other during these almost like mock code reviews of our solutions.
Sounds good. Sounds good.
Okay, so let's get into it. We are, let's see, day 14, right? Yeah. I will see if I can find my screen and share the question for this week. So day 14, extended polymerization. Okay. I guess I'll start reading this one. I think you guys covered the last one. The incredible pressures at this depth are starting to put a strain on your submarine. The submarine has polymerization equipment. Ooh. So it's like, yeah, it's like a replicator then, right? Yeah. Pretty much making it. Can you make another submarine inside your submarine?
Apparently you can.
That would produce suitable materials to reinforce a submarine. Yeah, if you create the materials that can help reinforce a submarine, then maybe you can create another submarine in a submarine.
Probably.
And the nearby volcanically active cave should even have the necessary input elements in sufficient quantities. Oh,
it's convenient.
Yeah, it takes it from your environment, all the materials. You don't have to take down like tanks. Anyway, the submarine manual contains instructions for finding the optimal polymer formula. Specifically, it offers a polymer template and a list of pair insertion rules, which is your puzzle input. You just need to work out what polymer would result after repeating the pair insertion process a few times. And so they're going to give us an input, for example, NNCB, and then some insertion rules. And essentially, the left hand is our matching, where if we find a C and H together, for example, then we're going to put a B in between. The second one, if there's two H's in a row, we're going to put an N between them, and so on. So the first line is the polymer template. This is the starting point of the process. The following section defines the pair insertion rules. A rule like AB, arrow C, means that when elements A and B are immediately adjacent, element C should be inserted between them. These insertions all happen simultaneously. So starting with the polymer template NNCB, the first step simultaneously considers all three pairs. The first pair, NN, matches the rule NN to C. So the element C is inserted between the first N and the second N. The second pair is NC, which matches the rule NC. So we're going with the first pair, which is NN, and then we're going to the second pair afterwards, which is NC. And with NC, it matches the rule NC to B, which was down here. And so the element B is inserted between the N and the C. The third pair, CB, matches the rule CB to H. And so element H is inserted between the C and B. Note that these pairs overlap. The second element of one pair is the first element of the next pair. Also, because all pairs are considered simultaneously, inserted elements are not considered to be part of a pair until the next step. So after the first step of this process, the polymer becomes NCNECHB, and it's also listed out here. But essentially there was something inserted between the two ends, which is the C, something inserted between the N and the C, which was this B, and something inserted within the C and the B, which was this H. And that step continues on. The polymer grows quickly. After step 5, it has a length of 97. After step 10, it has a length of 3,073. And after step 10, B occurs 1,749 times, C occurs 298 times, H occurs 161 times, and N occurs 865 times. Taking the quantity of the most common element, B, which appeared 1,749 times, and subtracting the quantity of the least common element, which is 161 times, produces 1,588. So you need to apply 10 steps of pair insertions to the polymer template to find the most and least common elements of the result. What do you get if you take the quantity of the most common element, subtract the quantity of the least common element? And of course, that means on your input. So I think I even tried just typing, oh, maybe it's a trick question, 150, 1,588. Because it didn't say to do it with my input, but anyways, that was obviously not the right answer. So they mean to do it with your input. So given your input, what is the most common, after step 10 steps, what's the most common, the least common, and the difference between them?
All right, it's probably going to be a quite large number. After only 10 steps, it grew to 3,073 length.
Yeah, and that's just starting out with
really
4.
fast.
Yeah,
Wow.
that's just starting out with 4. Right? And I think the puzzle input, I don't remember exactly, but it was over 10, I think, the one that I had.
I'll check my input real quick.
Bottom, the very last one, yeah.
Mine looks like, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
20.
14, 15, 16, 17, 20.
Yeah.
Mine starts at 20. And there are a lot of rules too.
Yeah.
So it's gonna grow quickly.
Yeah. So anyways, so that is the puzzle for day 14. Interesting.
All right. Any guesses on what part 2 could be?
Yeah.
What
More steps. More steps.
I'm thinking this one's just going to be an extension one where, okay, we did step 10 now. Now let's do, step 100.
Yeah.
And it's going to be some giant number that crashes your computer because it's too much for your memory.
Another scale in the timer space. Okay, any questions on this one? No? Okay. Let's go over 15. Okay, day 15, which just released 20 minutes ago.
All right. Nobody finished it yet, did they?
It's the first time I've seen it. So who wants to go over it? Scott?
Sure, I'll read this one. Day 15, chitin. You've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit that. The main problem is that the walls of the cave are covered in chitins, and it would be best not to bump any of them. Do you want to click on the link so we can see what the chitins are? They're these weird little sea creatures.
Chitins.
I'm pretty sure I'm pronouncing that correctly, right? It's not chicken. Yeah, it has the IPA there, chitins.
Oh, so it's been moved by us. Yeah, I'll move our. Oh, you guys can see it. Okay.
Yeah,
I can. Yeah, mine is the.
These weird little shell creatures. Okay.
Oh, so we're not so small. Sorry. This
Oh,
gumboot chitin is pretty large. Okay.
All right. So these sea creatures all over the side walls of the cave.
Sure.
All right. Well, it'd be best not to bump any of them. The cavern is large, but has a very low ceiling, restricting your motion to 2 dimensions. The shape of the cavern resembles a square. A quick scan of chitin density produces a map of risk level throughout the cave, your puzzle input. For example, 1, 1, 6, 3, 7, blah, blah, blah. There's a big grid of numbers. You start in the top left position, so that's number 1. Your destination is the bottom right position, and again, that's a number 1 in this sample input. And you cannot move diagonally, no diagonals. The number at each position is its risk level. To determine the total risk of an entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Okay, so we're probably not going to add our starting position. Your goal is to find a path with the lowest total risk. In this example, a path with the lowest total risk is highlighted here. And we can see it starts by going down. It goes 1, 1, 2, and then it turns, it goes 1, 3, 6, 5, 1, 1. Then it goes down, and then it turns again, and down, and to the side, and down, and finally it ends up at the bottom corner. The total risk of this path is 40. The starting position is never entered, so its risk is not counted. So if we summed up all of those highlighted numbers, except for the first corner, it would be 40.
Okay.
What is the lowest total risk of any path from the top left to the bottom right for your input?
Kind of seems like our puzzle that we did before with the lowest point, right? There was valleys.
Clouds. Yeah, clouds flow into.
Yeah, something like that. Yeah, the clouds flow into the valleys, so we have to find like the biggest depressions of the valleys or whatnot.
Seems similar, yeah. I'm gonna check my input real quick. Just wow, my input is a lot more than a 10 by 10 grid.
That's my problem.
Oh no.
That's my
I
problem.
always make,
I can always just do this on paper,
yeah,
but then the bound comes out.
on the sample, it always work.
Yeah.
Maybe with the actual puzzle, it may lower it.
Wow.
I'm guessing it's at least 100 by 100.
Yeah.
Probably even
Really
bigger.
fair.
All right.
So we got a 1 order of magnitude increase in the input size, but no, I think it's at least we're only restricted to the cardinal movements, right? Cardinal movements up, down, left, right.
Yeah.
Who knows? Maybe part 2 will be about diagonals too.
Yeah.
So we have to find the best path with the lowest risk and calculate what that risk is. Wow. It seems like it could be really hard actually, because you have to consider the entire path.
Yeah.
For example, maybe I'm at a position with risk level 1, and adjacent to me is risk level 1 and risk level 5. But maybe if I go to the risk level 1, then the next one from there will not be as efficient as going to the risk level 5 part first.
Yeah.
So you can't just think in the moment, you have to think the bigger picture, the total path.
Right.
Wow.
So I'm also
I think.
thinking maybe we'll have to sum up we might have to find all the possible passes and calculate the total risk and find the one with the least total amount maybe.
Yeah.
Hmm.
Yeah.
Yeah. Well, anyways, outside of speculation in part 2, part 1, is it pretty clear?
Yeah.
I think, a general depth first search might apply here, but we'll see. That's my immediate kind of take on it without more thoughts, but we'll see how that goes. That would probably be my initial approach to this one.
You see, that is a clear question. I understand.
Even in this sample input, I see a part where, for example, almost right in the middle of it, it goes down 1, 1, 2, 1, 3, 6, and then from that 6, they went to the 5 that's to the right of it, whereas the number right below is a 4, which is a lower risk,
Yeah.
and even below that 4 is a 3. So it seems like that could be an efficient path. That 6 to the 4,
Mhm.
but apparently it's more efficient to go on to the 5, which is a higher risk than the one right below it, because the 5 has a 1 path next to it. All right, so this seems fun. A little bit involved.
Cool.
All right, so we go on to, well, that's the most recent question. So we go on to our answers for part 6?
Yeah.
For day 6?
If you have no further questions, then let's go on to our answers. You're good?
All right.
All right. Joe, you good?
Yep. Good to go.
Do it. So who wants to start day 6?
Can we review the question?
So yeah, let's review the question a little bit.
Let's see, we'll review. Oh, well, okay, so we'll first review part 1, right?
Yeah.
This window, let's go back and crash. Okay, so this was lanternfish. Okay.
Lanternfish reproducing exponentially.
Yeah, exponential reproduction. So, well, essentially, there's a bunch of fish, and as you said before, there is a certain life cycle of this fish where adults that continuously reproduce every 6 days produce kids. The kids only take 8 days to become adults and do their first round of reproduction. But then after that, they're considered adults, only take 6 days to do the reproduction, right?
They only have one baby every time too.
Yeah, each time they only have one baby. So, and the question essentially says that after 80 days, how many fish do you have?
Right.
So you start out with however many your puzzle input is. You start out with the sample has you start out with 5, and then you can kind of see in the table here how fast and how quickly the stuff starts to grow. But it's an interesting question because I think for part 1 at least I took the naive approach and brute forced it.
Yeah, same thing.
We'll get to part 2 later. Part 1.
I tried also.
Part 1.
It's easy enough to try.
But that whole cycle of so there's a 6-day cycle for adults, an 8-day cycle for the first cycle for the kid before it becomes an adult and starts reproducing. And so how do you codify that? How do we make that into code so that after 80 cycles of this, how many fish do you end up with? So who wants to start up with solutions?
I can start.
I will start.
Oh, okay, Farouk.
Farouk, right?
Yeah.
Starting out with Python.
Yeah. So I also brute forced the part 1 because it seemed simple. So I have a simulate growth function here, and I'm passing my sample input as an array of strings separated by a comma. So if you can see my input here, this is my initial input at the beginning. So I have a range for the number of days. Now I have set it to 10 to make it more readable. So every day I'm looping through my entire loop, and if it doesn't equal to 0, I'm decrementing it by 1. And if it equals to 0, I'm setting that number to 6 and appending 8 to the end of the loop as a new lanternfish. So if you see the simulation a little bit, it's going like this. After the day 1, we have 1 0, and the next day this 0 becomes 6, and we have 1 8, and this 0 becomes 6 here, and we have 1 more 8 because of this 0. Yeah.
So you're
at the end of the
you're going through every day, and you're decrementing everything by 1.
Yeah.
And if anything ends up being 6 in your decrements, because but at some point you're going to enter a negative range, right? Because if you keep subtracting by 1, you're going to enter a negative range.
Yeah. So in order to avoid that, I'm setting that 0 to 6 and appending 8 to the end of the loop. And at the end, I'm returning the length of the list.
Okay.
So for example, you can set it to 80.
To 6, and then you add a child at the end.
So I have my input as, for part 1 it was enough, but for part 2, it wasn't enough.
We'll get to that later.
Yeah. Okay, cool.
I guess I'll share next because I did it in JavaScript, but it's the exact same as Farouk's. So let me share my screen. Can you see everything okay?
Yep.
All right, so I just added a bunch of comments. That's why it looks a little bit longer. But essentially, I just get my input. I printed out the sample input right here. It's just an array of numbers. And I loop through that. I loop 80 times. I capture my input at the beginning of the loop, or the length of my input, so that I don't loop beyond the original length, because I don't want to decrement new babies during that initial loop. They'll only decrement during the next loop. So then I loop inside of there through the entire length of the entire original length. And yeah, if my lanternfish has a timer that's greater than 0, then I'm going to decrement it. If its timer is 0, then I'm going to reset that lanternfish to 6, and I'm going to add a new baby lanternfish to the end with the value of 8.
Okay.
And that's all. Now we just need to print out the length. Quite simple, essentially the exact same as for roots.
Cool.
All right.
Any questions or so far?
No.
This was almost a nice break. I feel like day 3 was quite involved. Day 4, I can't remember day 4, but day 5 was a little bit longer too. Day 6 was a nice little break. Part 1 was so easy. Luckily, part 1 worked with just the brute force method.
Yeah, it took really like 10 minutes for that one, but part 2 was like, oh. Okay, so also in JavaScript. So just import my puzzle. That's actually what it looks like. It's just an array of number. I created an array for all the lanternfish. I will insert in it soon. Then first loop, it's for the amount of day. So in our case, it's 80 days. And then for this one, there is actually for each. Okay, so first there is nothing inserted the very first time. And then after that, I'm looping through the puzzle. And the puzzle, I just check if it's 0, means that's the end of the cycle. So I just push 1 to the lanternfish. And then I reset also that day to 6. And if it's not, I just decrement by 1 every time. It's exactly the same. But I just got 2 array. And at the end, just give the length of the puzzle. You remember the same?
Yeah.
Just, yeah, the fact I'm using a second array instead of doing only 1.
So you're pretty much just copying that array into a new array every round, and resetting the original array?
Yeah.
Okay. Cool.
Yeah, that's it.
Okay. And I will share mine. So unfortunately, I was not as intelligent as you guys. I read the question a little bit, probably too literally. And so the patterns I found was, oh, when it's a 6, I had a child, not when it's a 0, right? And that like made me go in all wonky directions, but I was still able to brute force it. So when you're reading through the code, remember that I'm doing like a pre-behavior or a post-behavior rather than pre-behavior, where you guys are waiting. As soon as you hit 0, then okay, reset to 6, and then add a child, which is I think the right way to do it.
Yeah.
Right.
Well, it wasn't immediately when it hits 0. It can drop from 1 to 0.
Right, but the next step,
the next round,
when you're processing that 0,
yeah,
that's
when you process
it,
0,
and that's
it adds a big thing.
the much better way to do it than when I did it. When I was like, oh, it's a 6 now, I must be kidding. Because then like the 8 ends up being a problem because the 8 passes through a 6 once before it gets to 0. But anyways, aside from that craziness, I'll explain to you how I was still able to get the answer. So a lot of the beginning part of my code is formatting, right? Trying to get the thing that I want up to about there. So I get it at the end of it. I just want a vector of integers. I just want a list of numbers so I can deal with strings. We'll get to the next day in a second, but essentially, other than that, I just have a cycles function or a cycles loop. I had to do 80 plus 1 because I started out with 1, but that was just really for my output. So that my output, I can say day 1, day 2, day 3. So I do a couple weird things just for the sake of having an output a certain way so that I can see whether or not things are happening the way I thought they're going to happen. So anyways, I create another array, which I probably didn't have to do because I didn't want to change my original array. But looking at it now, I think that's kind of ridiculous because I never used that original array anyway. So I might as well just mutate the original array. Anyways, so I pass something to next day and then I get it back and then run the cycle, use it yesterday or the next day's results, get a new result, and then use the day after the results. So each day I'm using the previous day's results. So I'm cycling through that way. The function itself, pretty similar to what you guys have had, except again, no. Looking at my code again.
You're also checking for, you're
Look
checking
at my code
for
again.
0.
Never mind. Look at my code again, Dave. Part A, I was okay, and part B, my brain just completely like went in another direction. But now I look at my code, it's exactly the same.
The same, yeah.
So it doesn't-
you are checking for 0 and appending 8.
and I'm reacting to the zeros. Yeah. Okay. So then there's nothing to see here. It's pretty much the same thing, just written in Rust.
And yeah, you remove 1.
Yeah. Okay. So maybe part 2 will be more interesting. And since I'm the last one, I'll go directly to part 2. Now, I had a lot of problems with part 2.
So first, what was part 2?
Part 2 was we do the same thing.
Not only you.
256.
Was it 250? I'm sorry,
Yeah.
256. Part A was 80. Part 2 was 256. And things after like 120, you start noticing, oh, it's slowing down. After 150, you're like, oh, this is slow. And after 180 to near 200, you're like, okay, this is not going to happen. This is not going to happen before I leave work today. So that's it. I had to reassess, but I want to kind of show you guys my battlefield. So if you can see on the right side, all that green, that is all different code I've tried. And that's not even the entirety of it, right? Because even that was massaged again and again and again and again, and then I gave up. And I tried another thing and then massaged that again and again and again and again, and I gave up. So I tried a lot of things, a lot of things. Obviously not very successful. So initially, of course, is a brute force method, right?
Yeah.
Where, okay, this ain't gonna work.
80, I think we all try from 80 to put 256.
Yeah, and you can see it down
Change
here.
one number.
Yeah, I was like 250. Okay, when does it start getting weird? So things like, oh, 64 is okay, 80 is okay, and so on, and whatever. And then I started printing out more things just to see, where things getting weird. Maybe I can find some like patterns in the way that the number has been increasing. Like, can I find patterns in the gaps between numbers, or I don't know. But anyways, a lot of strain, a lot of headache, a lot of heartache. Yeah. Counting juveniles versus adults, contemplating for cycles. So I, for some reason, abandoned new number acting on whether the number equals 0 and started acting on when the number equals 6. Yeah, I don't know. I was desperate, and desperation leads to very bad decision making. And that all this code is just my little wall of shame. But I will like to share it with you because I think sometimes life is nothing but a wall of shame, and you just have to keep going. You just keep going. So what I ended up doing at the end, which I'm still not particularly fond of or proud of, because so what had happened is I went through all this. Even with brute forcing, I found a way to somewhat brute force it within 200 seconds.
That's quick. No, that's really quick, actually, for a problem this big.
But I was like, this is not really probably what they were looking for. So then, but it got to today and I hadn't come up with anything yet. So I started looking up this morning, I started looking up what other people had done, and regardless of the language. And that's when it just like smacked me in the side of the face. I did this completely wrong. Completely wrong. But I'll show you the way that I did it. With that caveat in mind, don't do it my way. So
Is this the brute force way then?
this is
Okay.
a brute force-ish way.
Okay.
And the way that I did this one is, okay, I know there's 256 days. I know that each child's going to have a number of children as the generations go by, as the days go by, as the ticks go by. And so I need to figure out how many children they're going to produce at every cycle.
Based on the starting value?
Based on the starting value.
Okay.
And so, for example, and I did it not really on a day-to-day basis, but on a columnar basis. So let's go back to the actual input and I'll show you the madness of my brain. And so I was looking through this and I was like, oh, look, this column has 1, 6, 2, 6, 3, 6. And this column, and I did this for all the columns and I was, yeah, like.
I checked, it took me a really long time also. I checked so many patterns. I was like also on paper. I was like, wait, yeah, same as day 8, right? Same as the.
So desperate to find a pattern in the numbers.
Yes.
that I started trying to rationalize a way. There's got to be an algorithm to figure out how to do this. And so that's what I did. So for this column, I realized that the 3s and the 3s will have the same number. Right? Because a fish that starts with a day 3 over the course of the 256 days will have an entire family tree that includes the same number as another fish with day 3. So I created a family tree for 256 days for 3. I created a family tree for the day for the 4. But I didn't have to do, I realized, all the days. I only had to do the number of days that were included in my puzzle input. And I realized only half the numbers are included. They only went from 0 to 5 for some reason.
Right. Yeah.
Or a certain number, right? And so I brute force 0 through 5.
Okay.
And then I added the numbers together. So that's my approach. So I brute force all the possible children for a fish that starts within 0 through 5. So let's go back to my solution and see what that weirdness is like. And so I pass on, we'll come back to this get children function in a second. So get the fish amount for only the digits of the input and create a lookup table of amounts. And so this is where the brute force happens. So I get the number of inputs. Fortunately, I looked through the puzzle input itself and I realized everything's less than 10. Right, because there's no double-digit numbers like 11 or 12 or whatever. Everything. Plus, it only goes up to 8.
Yeah,
right?
8 was the maximum.
Yeah. So it's like, all right, I'll create a vector between 0 to 10, and so it almost looks like I'm going in the right direction. But then I fall off the rails. So I add in all the unique numbers, and then for each of the unique number or each of the numbers, I get the children. And for me, the numbers I get for each. So for like example, I know for 3, for day 3, I have 1 day 3. If we want for the sample, we have 2 day 3, 1 day 1, 1 day 2, and 1 day 4. So that's kind of what I end up with my unique numbers, is I kind of get a number for each day. And again, it looks like I'm going in the right direction. Then I call get children on these, and the get children will take those and we'll start to try to mathematically determine the number of children, the family tree of this kid, the number of children it has by taking, okay, it's got a number of children, it's got a certain offset, it's going to have another child. Okay, I'm going to do a recursion into that child and see how many children that child's going to have. And then take that firstborn and do another child tree for that one. And then come back after I get all the firstborns to get a firstborn that doesn't have any children, it's too young to have children. I'm going to go back one and see if the past children had any subchildren, and then do that subchild and see if it's been alive long enough to have another child. And that way, basically checking every child in the family tree to see whether or not it's possible that they have children. If they do, see how many children they have, and so on and so forth. Crazy. It's crazy. But it brute forces for every number how many you can expect out of that family tree, starting with that number. But the optimization, you could call it that, was I only limited it to the numbers that were in my puzzle input, which happened to be only the first 5 numbers. And then add up the necessary amounts. So using that lookup table of all the numbers, I see what numbers are in mine, and mine was like 4, 1, 0, 0, 0. So for the 4, I already know the 4 tree is going to have this many children, one's going to have this many children, zero's going to have this many children. I don't have to actually recurse to the trees again, which is what was the original brute force method. Was we did the recursion for every number that came through. So that saved me a lot of time, especially since I think my input was like, was 100 elements long or something like that? No, maybe not that long. It was quite a few elements long. Actually, take a look at it. Is it 200?
Or even more, actually.
Yeah. And so I didn't have to do it for, I didn't have to do the entire, like, how many child does this thing we have for every number, because I knew that, you know, all the ones are going to be the same, all the twos are going to be the same. So I just used that first table as a lookup table to figure out how many children is this particular fish going to have. And then I added up all those. So, and then, so I was like, you know, like I said before, this can't be the way. And so this morning I looked up other people who did it, and it's like a brick to the side of the head. Like, oh my God. Completely, I almost got it because, you know, the unique numbers I got, oh, okay, this, you know, this says something. But then realizing that instead of focusing on the replication of each child and their child and children's child and the child's child and the child's child, I could have focused on the calendar. And on each day, how many kids are being made on each day. And then these numbers are only how many days out before that number reaches today. And so basically creating a calendar and then have that calendar come to, and it's like, oh my God. So I rewrote it. I thought I pushed it, but maybe I didn't.
It looked like you had it commented out at the bottom.
No,
That was another.
that's the lookup table that was generated, because I thought, oh, hey, this is kind of maybe neat. So for each of these fish, this is the lookup table for each of these
That
fish.
looks useful. That looks like what you should do.
So, but then I realized that there's only
Although I don't know
0
why you
through
have
4.
index 9.
Yeah, there's only 0 through 4 in my input, probably in
Okay.
your input too. So basically I had, for every place, I had to add up this number of fish. But, so then I did the second way, and I'm gonna refresh really quick to see, maybe I didn't push, I thought I pushed, but anyways, the second way I did it was with the calendar. And then even with reading through other people's solutions, I realized Rust has a very interesting data structure called it's a vector, but it's called a vector DQ, which is essentially their quasi implementation of a ring buffer. And the ring buffer is really nice in this because as an adult reaches the point where they give birth, they go back in the queue, and they basically have this thing where it just keeps cycling, right? And so that's a good application of that kind of ring buffer. The only caveat is that it only goes back once, but it needs to go back to day 6. But then the same number always goes back to day 8 anyways as new kids. So really you just have to make sure that adults are accounted for on day 6. And so I rewrote it. Let's see if I can find it on here. No, I don't have it. I'll share it, or you guys can find it later on in the in my repo. But this one took about 180 seconds or 180, 300, depending on the computer. So about 200 seconds. The new one was 200 microseconds. But I'm not going to get too much into how exactly it was implemented, because you guys probably implemented that way. So I want to see what you guys had done first. But that was my madness for 6B.
Especially when you went through the first one in 5-10 minutes, and
Yeah.
then the second one it took like hours.
It took a couple of days. So I got the optimization by the end of the first day, but I was like, no, this can't be it. And I just kept hacking away and hacking away, and whatever. Never really got anywhere happy.
Oh, right. Should I show mine now?
So, yeah, let's do it.
All right, let me share my screen now. All right, well, I think like Alexei has already mentioned, most of us initially tried to reuse our part 1 code and just loop it 256 times instead of 80. And what I noticed when that happened was my code ran for about 10 seconds, my fans started spinning up, and then it threw a full JavaScript error, overflow. And so I realized, yeah, that's actually probably expected because my final answer probably going to be in the hundreds of billions, trillions. And I think I read that the maximum length for an array in JavaScript is about 4 point something billion. So my array was getting way beyond the maximum possible array that you can have in JavaScript. And my RAM was all being used up for all of my array elements because I was actually adding an element to my array every time a fish was born. My array just kept getting longer and longer. So that was out. But luckily, I remembered from doing Argonauts last year that pretty much anytime I have an issue like this with runtime taking too long, memory getting used up too much, usually it's because I'm using arrays where I should be using objects or hash maps. So I decided to create an object to hold all of my fish maps. And I realized that the only thing I really need is how many fish have a certain internal timer. So how many fish are at timer 0, timer 1, timer 2, 3, 4, 5, 6, and we only go up to timer 8. So I created my initial object. I just set everything to 0. There are no fish at the beginning. And then I had to populate that with my input. So I looped through every element in my input and added a fish to my object. If there was no fish, I added 1. If there was already a fish there, then I just incremented it. So at the end, this fish's object had the number of fish index, or with each internal timer. And then all I had to do was create a loop that ran 256 times. I first copied my object, I made a copy of my fishy's object because I didn't want it to be changing while I'm looping. I wanted the initial object to stay the same for that loop. So I created it just temp because it's a temporary object. So then I just searched through how many fishes had that internal timer. So, well, so I made all of my fish with internal timer 1 will go down to 0 because all of them are just going down. So any fish that had a timer of 1 is now going to have a timer of 0. Any fish with a timer of 2 has a timer of 1. So the total number of fish was being copied over to my fish's array. And the only things that were a little bit special were for 6 and 7. So any fish that previously was at timer 7 will now be at timer 6. But also any fish that were at 0 will now be at 6 also, because any adult fish that had a baby resets to 6. So 6, I had to just add the total number that were at timer 7 and the total number of fish that were at timer 0. Likewise, for fishies at timer 8, I had to, again, take my total number of fishies at timer 0. And now those are all of the babies now, the new fish. They start at timer 8. And now my final object is going to have the total number of fish at each internal timer at the end of 256 rounds. So all I have to do is sum up all of the values in my object there.
Yeah.
And that was my final answer.
So you create a calendar 8 days or 9 days out, and then basically everybody marches towards 0, right? Where things that are in the beginning of the line just end up back at the end of the line and at day 6. But you're an 8-day out schedule where everything's just coming closer and closer at every cycle.
Yeah.
You could have actually done because that movement is also just a queue. Yeah. So I think you might have just been able to do a shift.
I give you a queue.
Okay.
Just pull it off the front, stick it to the rear, and then a special provision for day 6.
Yeah.
So a shift, a pop, and an insert.
Yeah.
Or a shift, a pop, and just a mutation on day 6. Or I did on day 6.
All right.
Cool.
If Alexa did it that way, let's see it.
That makes a lot more sense.
And this ran in, I don't know how long it took. It was definitely way under a second. It was pretty much instant. I clicked run and I got the answer.
Okay, it was like 37. I was like, but where do you increment? I was like, I couldn't see. It's like, where is the increment? Because if you can 10, 1, 2, I was sorry, it was always 0.
Sorry, do you want me to share again?
No, it's okay.
Because line 37 really wasn't anything about that. Line 37 was just to get my initial input into my object, into my fishes object.
Your first fish.
Yeah, this is my initial fish population.
So in the
Okay.
in the sample, there's one fish 3 days. There's 2 fish 3 days out, 1 fish 1 day out, 1 fish 2 days out, and 1 fish 4 days out.
So what do you mean? Where do I increment? So I have a loop, and I'm just looping 256 times, and I'm capturing the total number of fish with that internal timer. So for example, any fish that has an internal timer of 1, on the next day, they're going to have an internal timer of 0. So I copied the previous values, the previous number of fish that had timer 1 are now going to be the fish that have timer 0. So they're just getting copied here. So so the value from the 1 index is just getting copied over to the 0 index.
Yeah, but I was saying like the 10.
Yeah.
I thought it was like 0 all the time. But
Oh my!
because
From this
at
one?
line 37, you actually implement fishes.
Yeah, that's why I populate my
You populate fishes at 37,
Okay.
so that's why
Yeah.
it's like. Otherwise, I think the 10 is always
Just
gonna be
gonna be
0.
It's got a million zeros everywhere.
Moving the zeros around.
All right. Let's see how you did it. Let's see.
It took me really long time. All right. So of course, as Scott says, I tried 56, computer blow up. I tried to sneak and increase the memory for the node. Didn't work at all.
Multiple times.
Of course.
My first thing was node script.js run and fatal error. So of course my first thing was, well, let's try it again.
That can't be right.
Yeah.
Maybe I'll have more memory now.
It was minus
Shut down your browser.
I went to the terrace, tried to run it outside.
It should work.
Yeah, maybe it's just too hot.
So I came up with the idea of Q. I searched because obviously I couldn't think of anything else. So I found like people were talking about Q. So I was like, okay, yeah, it's always the same pattern. So I just created an array with a size of 9 because it doesn't count as 0. So we need to count 0 to 8 for fish. And then first I populate the queue with the right fish, the position with the right number. And then after that I loop the amount of day. And then I just remove the first one, then place it at the end. And then at the the one we just removed.
Yeah. So you'll have like 6 fish removed, and then that becomes the new generation of kids. So that's pushed to the end.
Yeah.
But then those 6 also are the adults that will repopulate starting from day 6.
Exactly.
Or day 6 days from now.
Yeah. So then actually the array is always the same size. It's always like 9, and then I just need to calculate like to sum all the number of this array. So day 1 there is maybe 5.
You use the reduce.
Yes.
Nice.
Since you kept talking about reduce, I could reduce. But yeah, when I figured it out, it was like, yeah, so much faster, easy instinct.
So essentially that would be doing the exact same thing as mine, except you're using an array and I'm using an object.
Yeah.
So you're using an array too. Weren't you? You're using an object? I thought you were using an array. Because you were using
I was using the number index as the key in my object.
A sequential key starting from 0 to 9.
Yeah.
This is an array, man.
Should have been an array.
Okay.
But yeah, okay. But yeah, it's exactly the same. Except you couldn't have used shift and pop there because yours was an object.
I limited myself.
Cut yourself off at the knees. But yeah.
Well, it took me like to come up with this, and then people were talking on Stack Overflow. You're like, yeah, when you run out of this, maybe you should try Q. Okay, let me look at Q. But okay, I think I can implement it. Yeah.
Well, I didn't even come up with it. I had to look it up on the internet and find out I was, I was doing the wrong thing, but obviously wrong. Farouk?
Yeah, all right. Sharing my screen. Okay. So my first approach was one similar you mentioned, Alex. You're mentioning counting the children that each day will have at the end of the cycle. For example, after 80 days, how many children will the ones with 3 have, and how many children ones with 4 have? But I couldn't get to the end of it. Every time I was getting confused counting the entire generation.
Yeah, there's a lot of offsets
Because,
to figure out.
yeah, they will have zeros on different days of the cycle, and 8s are born on those days, and those 8s will have their own generation.
Right.
So after, it took me around 3 days too, but then I realized we can just sum get the count of how many fish do we have at the beginning of the cycle. For example, how many do you have is 1, etc. And every day you can decrement. For example, let's say we have 1 fish with day 1 today, and 2, we have 1 fish with 2 interval, we have 1, and every day they will go 1 down, right? So all the ones with 1 day interval will go to 0, and all the ones with 2 interval will go to 1, and etc. And the ones on 0 will have kids here, and they increment 8 too. So basically a counter, frequency counter or calendar you guys mentioned. So I have 200 days here, and I'm counting the zeros, how many zeros I will have. For example, in my count, let's say I have 1 0 here, but after 1 day I have 1 0, right? So when I have it, I do not change anything. I will just store this in a different variable, because if I add this to 6 right now, on the day which there is 0, my 6 will also decrement to 5. In order to avoid this, I'll just store zeros on a different variable, and after the loop is done, after the day is over, I will add my zeros to 6 and increment that number of 8s. So my zeros will increment 6 because they will set to 6, and it will also add that many number of 8s to my calendar or dictionary, so to say. So at the end, it will give me the count of how many of each interval I'm ending up with. Let's say 10. Yeah, so at the end, I will have the number of each interval in my dictionary.
Yeah.
Can you explain to me the significance of the zeros?
That's because when a fish gets to 0, it spawns.
Yeah, let me explain,
okay.
because
it resets
when it gets to 0 here, it's a 1 loop. So I have my 0, right? In here, I have 1 0, for example. Let's say I have 1 0. When it reaches to 0, if I set my 0 count to 0 and increment 6 by 1 and 8 by 1, on the same cycle, they will decrement. My 6 will go to 5, and my 8 will go to 7 on the same cycle. But what I want is, I want this to happen on the next cycle. So that's why I just store the zeros and add those at the end of the loop, so that the decrementing will happen on the next cycle.
Okay.
Not on the same cycle.
Right.
Yeah. So at the end, I also just need to sum up the counts of each interval to get the total.
Cool.
It reminds me, you were talking about the array Even think like one array is not enough. It's like more than one.
Yeah.
So
Just chop it up.
I was trying to split into arrays, and but it quickly went like this. So it was impossible to track. It's like, yeah, it's something like
This was a fun one. If you started thinking the right way, then it wasn't that hard. But if you started thinking the wrong way, it was
painful. It's very, very painful. And then, the interesting thing, at least for my code, I don't have it, unfortunately. I thought I pushed it, but I didn't. But day two's code was shorter than day one code. And so it's basically a complete reapproach, or not day two, for part two than it was for part one. But forced upon you because of the inability for the first solution to scale. Which doesn't necessarily say that I should have spent more time on my part one solution to make it scalable. Like I said, it's premature optimization. You don't know if it's really going to happen or not. But it's interesting that this part two was start from scratch again. Figure out a better way to do this on a larger scale.
I think day 15, day 14, yesterday's was also similar to the lantern fish.
Yeah, and I don't think I have a solution yet for part B, but I now have new insights as to what my problem might be. It might be that I need to rethink this whole thing.
gotta catch up, guys.
Could I share my part one for problem 6?
Yeah, go ahead, please. Yeah.
Okay.
Yeah, just I do it on the back. I can only get up to part 1, but
Oh, that's cool. That's cool. The more the merrier.
Yeah, I got it.
you guys see my screen?
Yeah.
So
you pasted yours in. Nice.
So here was my input, and I think I just used pretty much the same approach as everyone else, but basically I just initialize a count to 0, and I just basically convert every, I guess, starting life count to a tuple, where I guess the first element in the tuple is I guess how many lives the fish has, and the second element in the tuple is how many days are left in the counter for that fish. And I just put everything in a queue. And while there's still elements in the queue, I pop off an element off the queue. I guess I don't think it actually matters if it's a queue or a stack or whatever, but yeah, I just pop off an element and split up the tuple values into how many lives the fish has left and how many days are left on the counter. And for every fish I pop off, I just increment my total count by 1. And then I just go through, I guess, one through however many days left, however many days are left on that fish's counter. And if the fish has run out of lives, then I just, if the fish still has lives left, then I just decrement that fish's life count by 1. Otherwise, I just reset the fish's life back to 6, create a new fish, and then append that new fish to the queue. And at the very end, I return the counts. And yeah, it seems to work for the part 1, but I tried it on part 2 and it just doesn't finish. So
try 256 instead of 8.
Yeah.
So I think it's interesting because yours uses. Can we see yours again, Joseph?
Oh, sure.
So you're also doing it on a per fish basis, where on each fish basis you're going through the range of days. So for the first fish you're going through 250 or 80 days in this case. Second fish you're going through 80 days. Third fish you're going through 80 days.
Right.
Okay, and then depending on how many days are left for each fish.
Yeah.
Cool. The stack wouldn't work, no? Yeah. The stack you cannot insert in the middle, can you?
I think maybe there could be some memorization.
Yeah, but with a queue, you can do
Right.
you know, either end.
Mhm.
But because it almost looks like if you enqueue the fish at 80 days while fishes, and you pop out the first one. Yeah, okay. That it was pretty much the same as yours. Because all of ours on part one, we're focused on the lives of the fish, each individual fish, the lives and the children of the fish. And then part two, we had to look at the calendar. How many fish, not so much focusing on the fish as it's focusing on how many fish are how many days out, where the calendar kind of determines that. So not really worried so much about the fish's children's children, but like, okay, 9 days out, how many fish are at that particular number of days out?
Yeah.
And so the queue just ends up being a queue of the amounts of fish rather than a queues of days per fish. And that made it that changed the processing to make it a lot faster. That's interesting. This is the first time I've seen DQ. I didn't realize that Python had it, so that's coming neat.
Yeah, doing interview prep just showed me a lot of hidden gems.
Nice. Cool. Yeah, because like I said, this is day 6 was also when I spoke about it before, but I was also introduced to a new structure called a vector DQ. And essentially it takes a vector and creates a queue out of the vector. And the queue has this thing where I can rotate the queue. And the rotating is basically the pop and or the shift and the push, or the pop and unshift. And so it does all that for me in one operation. I don't have to do the shift and the pop, or the pop or the unshift and the push
So confusing.
in 2 operations. And so, but yeah, I would have never discovered that, I don't think, in typical operation outside of this puzzle. So that was kind of a neat thing that I ended up with at the end of this puzzle, knowledge of a new data structure in Rust. Yeah.
Cool.
Rust is used for, you know.
Mostly backend. If you want something, essentially it's a memory slash, yeah, it's mostly memory, either on the security or the space basis. A memory safe, I would say, implementation of C, maybe even C++, but you know, I'm not sure there's classes in struct. I could be wrong, but I haven't found a reason to use classes. But I have used structs so far, and those are C structures. And so I would say, if you come from a C background and you don't want to deal with as much memory allocation, or you want the compiler to give you more warnings about when you're doing memory unsafe things, then it's a great language, because it's going to compile down to something just as fast, but you'll have this extra safety net that the compiler will tell you, hey, this is probably not going to work. This is probably going to either be a memory leak, or you're going to have some sort of unsafe operation where, you know, things will go out of scope before you even realize it. So you'll have null references or expired references, stuff like that. That takes care of, or gives you that safety net, or either warns you before you realize. But for someone coming out of like an interpreted language, or a language that doesn't use any kind of this strict memories, or, you know, yeah, mostly the memory issues, it's a bear. Because you have to now backfill all your knowledge, I think, with what exactly is happening and why you have to learn all these new idioms, new ways of programming. So not something I would push onto a first-time programmer.
I wasn't considering your needs, so.
I would say at some point you should, because it brings to light a lot of things you take for granted, I think, with interpreted loosely typed languages. Like I said, the biggest thing I've dealt with in the past, let's say now 15 days, is I'm just now getting comfortable with it, which is, you know, a shame, but we're all learning here. There's strings, there's STRs, and there's characters. And there's
These are all different
reference
things.
versions of each of those threes as well. And they're not always directly, well, you can't use them against each other. You can't make one, compare one against the other. You can't make one equal the other. You have to convert every time you go through these.
What is the difference between a string and an STR?
STRs are literals. Strings are actual constructs that you can actually use to populate things. And so if you just type in a literal, or if you read something from a file, it comes in as an STR. But then STR, those come in as STR references because you don't necessarily want to recreate them through your program. And so you don't really even use them as STRs, you use them as what are called borrowed STRs. Okay.
Yeah, that's okay. Okay, I need to look at the dog.
And because a lot of these puzzles deal with strings, it's just been like me pounding my head and like, why can't I take a reference of a string and turn it into a character? How do I do that? But I have a string, so then I have to cast it to a character, and then take the character as a string, but then it's a double reference. So do I have to take ownership, or do I have to borrow? It's yeah. And 15 days later, I'm now starting to kind of get the flow. Like, okay, about half the time I'll get it so the compiler doesn't tell me I'm doing it wrong. But yeah, whatever. At the end of it, hopefully I'll be a better Rust programmer. Anyway, so day 6, that was a whopper. And it's early too. I was like, I normally don't expect these until like after day 10. Like to be like broadsided on day 6 by this. It's gonna, that was a surprise for me too.
You're gonna lose me soon.
The next time we discuss day 7, I think that was the crabs that have to line up.
Oh, yeah?
Yes.
Okay. I remember it was, at least for me, it wasn't too
It wasn't
bad.
that hard.
It wasn't too bad until about day 14, and then we had another like scaling issue. And I was like, ah, here we go again. But
Day 11 was the hardest one for me so far. After day 10, there's day 11 with Dumbo octopuses. The flash out. That one was really hard for me.
Well, you still haven't done the day 12 one.
Huh?
You haven't finished day 12 yet, have you? The mapping
No,
one? You have
that's my birthday gift. I'm just keeping it. I don't want to open it yet.
you want to savor it, right?
Yeah.
Yeah, I'm
Perfect
savor it.
moment where like you're depressed, you feel bad about everything.
I
I want to do a puzzle.
Yeah, I want to solve it undistracted, you know.
The octopus one was difficult for me, but I got it.
Yeah.
All right, let's wrap it up for today. We're going to meet again on Friday. We're going to be going through day 17 and 16 for questions, and we'll go through the answers that we have for day 7. All right.
All right.
So thanks for joining, you guys. Thanks, Joseph. Hopefully we'll see you again on Friday. But if not, thanks for joining.
Yeah, this was fun.
Yeah, good. And anyone else who'd like to join, you're welcome to come join us.
Come.
The more the merrier.
Come with us.
Anyway, see you guys next time.
Good afternoon.
See you guys next time. Bye.